box of coins contains 4 quarters, 6 dimes, and 2 pennies. Determine the probability of drawing a dime and then drawing a quarter without replacement. How can I figure the probability of this problem, and what does it mean to be without replacement? Chloe is here with her latest tips and tricks. If you're trying to find the probability of an event, she wants you to know that you take the number of favorable outcomes and you divide it by the total number of outcomes. If you have an independent, it is the occurrence of one event has no effect on the probability of the next event. It's with replacement. So you'll take the probability of A and B equals the probability of A times the probability of B. Not independent or dependent. The occurrence of one event has an effect on the probability of the next event. It's without replacement. So it's the probability of A, then the probability of B, equals the probability of A times the probability of B after you have found A. Now that we have Chloe's tips and tricks, let's go ahead and find the probability of drawing a dime and then a quarter without replacement. So because this one is without replacement, it means that these two events are not independent. They are dependent of each other. The occurrence of one event does have an effect on the probability of the next event. If I pull a dime out of this bag and then I don't put the dime back in for the second event, when I pull that quarter during the second event, I have one less coin in the bag. Therefore, the probability of the second event pulling the quarter is affected by the probability of the first event pulling a dime. So when I look at my formula, I know that the probability of A then B is equal to the probability of A times the probability of B after you have found the probability of A. So in my example, I am taking the probability of pulling a dime out of the bag, then the probability of pulling a quarter. So for this, I'll have the probability of the dime multiplied by the probability of the quarter after I pull the dime. So the probability of pulling the dime, I have 6 dimes out of 4 plus 6 plus 2, 12 coins. So probability of pulling a dime, I have a 6 out of 12 chance. Now, I don't put that dime back in the bag. So instead of 12 coins, I now only have 11 coins in my bag. And when I go in to pull my quarter after I pulled that dime, well, how many quarters are there? 4. So I have 6 out of 12 dimes. Then I have 4 out of 11 for quarters. Then from here, I'm going to go ahead and you can see that 12 and 4 diagonally, we can reduce those by 4. 4 divided by 4 is 1, 12 divided by 4 is 3. So I really have 6 over 3 times 1 over 11. And then from here, I can multiply across. 6 times 1 is 6, 3 times 11 is 33. Then I can reduce here. I could divide each of these by 3. 6 divided by 3 is 2, and 33 divided by 3 is 11. So the probability of pulling a dime out of the bag and then a quarter after I have pulled the dime out and I did not replace the dime, the probability is a 2 out of 11.